Okay, so this is the video for 1.3 in case you missed anything. We'll fill in this sheet as we go. So the velocity, when we talk about velocity, it's the slope of a distance versus time graph. So if you have distance on the y-axis and time on the x-axis, the slope of that curve will represent the velocity of an object through space. Okay? We often refer to the velocity as the delta x over delta t, or the change in x over change in time. If the graph is not a straight line, then we use the slope of a tangent line drawn at that point. You can kind of see that over here in the pictures. At P, we're using a tangent there, and at Q, we use a tangent graph for that as well. And we can do that. Velocity is a vector, so it's not distance over time, it is displacement over time. Whereas speed is the scalar version, which does not have a direction, and you can just use distance over time. Over here you can see a quick little sketch of how you might go about creating this idea. If we needed to find the velocity of the ball at 2 seconds, what I ended up doing is I drew something that looked like a tangent that was right around 2 seconds. You can kind of see over here, where I keep booping the screen, that right around there is where 2 is. I drew a line that I tried to make as close to a tangent as bad as I could. It's not perfect. And then I looked at where it's hitting at 1 and 3, what those heights were. So I figured it's up at about, excuse me, okay. Okay, so it's up at about 4 centimeters at 3 seconds. Oh man, okay, there we go. It's up at about 4. At 1 second, it's about 1.9. So I did 4 minus 1.9 to find the height difference, or the position change, delta x. And then I divided that by delta t, the 2 seconds, from 1 second to 3 seconds. And I got roughly 1.05. It's centimeters on the y-axis and seconds there. And so we ended up with about 1.05. Yeah, it's a rough estimate. If anybody draws a different tangent line, they're going to get a slightly different answer. Now this is a position versus time graph, and what I really want to focus on is part B through D. What we have to understand about position versus time graphs is that the slope of the graph is the velocity. And so if I'm looking for a place where the velocity of this graph is high, meaning that it has a very positive value, I would be looking at places, whoops, thought I had that. There we go. I'd be looking at places like D, where the graph is trending upward. I is not quite as high, but it is trending up that way. And so those are places where I would say that this has a very high velocity, or a positive velocity. It's pretty big. A velocity being 0 means that the slope is 0. That would occur at places like C, E, G, and you might throw in L as well. I did just because I figured, oh, well, I can't say for sure, but it looks like it caps off, it turns to 0. And then when we want those negatives, TB has a negative slope and TF has a negative slope. So those would be places where we'd expect the object to be moving backwards, as evidenced by a negative velocity. All right. A really quick example of how we use velocity and how we use speed, and how they're different and they mean different things. A velocity, remember, is the displacement. If a bird travels 306 meters east, turns around and flies 406.5 meters west, the displacement, which is how we find velocity, is really the difference between those two. So you take 306 and you'd actually subtract the 406.5. Now if we called west positive and east negative, this would be positive 6.7 instead of negative 6.7. But what you have to remember is that whatever direction you head first, we're typically going to call that positive. And we divide it by 15 because it's change in position divided by change in time. Turns out this bird has a negative average velocity, and it's not very fast. Whereas if we look at its average speed, 306 plus 406.5, we add them because we're just looking at the distance traveled, not the direction it traveled. And we divide that by 15, we come up with a 47.5 meters per second, much faster. But if I was going to actually describe how fast the bird is, I certainly would want to emphasize its overall speed, not its velocity. You might say, well, Mr. Welch, this is dumb. Why don't we just always use speed? Speed doesn't work when we start to get into things like accelerations. Sometimes we're slowing down, and that won't always show up in a speed. There's issues that come up as we try to apply this to new ideas. And so we're going to stick with velocity and really use that direction to go with the magnitude to really make things more meaningful. And that's it.